Hello everyone. Welcome to the episode 28 in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. We continue with kernel space journey. The topic of this episode is tracing global behavior. And for example, we try to log send message API and also learn how to put breakpoints with some action. Just a small diagram to remind you of user sessions, desktops, windows, processes, and threads. For each user, there is a session. Each session can have many desktops, and also each desktop can have several windows. And also, for each process, there can be several threads, and each thread can create a window. Sometimes we need to trace window messages, either messages that were sent via post message API or via send message API directly to window procedure. But if we try to use traditional tools such as Spy++ or message history, then we can only trace messages in one desktop session. All other windows are inaccessible. Windows that belong to other users, to processes and threads that belong to other users. So last time I was asked how to do that. Is it possible to do it with Spy++ or message history? I said no, and then I thought maybe it's possible to do via live debugging. Because all these processes, when they try, for example, to send a message, they communicate to kernel. And for example, if we want to trace send message, then we can put a breakpoint in somewhere in kernel. And so this is the task of today's exercise, to trace send message API calls and also traditionally format them with window handle, message ID, and two parameters. So now we switch to WinDbg. I already run operating system in VMware. Actually, there are 4 sessions inside, 2 user sessions, and 1 switch to user session, and there is also system session. And WinDbg is already attached. And I also open the log file. So first of all, we check the number of sessions. We see there are 4 sessions on this machine. And for example, let's process 3. For example, we can see what sessions are in. So there is one, the last session, it corresponds to logon UI. You see here, it allows you to switch between existing user sessions. And all other sessions, for example, session 2, as process. You see usual processes such as Explorer, session ID 2, and session 1 is another user session, also has Explorer running. So suppose we want to trace send message API. So we may think that if there is send message API in user space, Win32 API, then there might be some kernel equivalent for it. Let's try if we find something in Win32K. This is user and graphic subsystem. So let's check if there's any send message. So you see there are a few functions here. I choose this one. This is because when I disassembled it, for example, no code found. This is because we need to switch to session that has graphical user interface. So let's make it session 1. Now we can switch to session 2, and here we are able to disassemble. So when we disassemble, we see actually we disassembled the wrong one. So we need this one, message to client. So if we disassemble this function, we see there is a reference to some functions, and we chose this function to put breakpoint because it references some processes. So by doing that, we think it finds the right process and threads to send message to. So what we do, let's create access breakpoint on this function and see if there are any breaks. Okay, so we get this breakpoint hit. Actually, don't see any prompt. This is because previously I used .prompt command and disabled all for example, if we put re-enable symbols, So we get some notification, such as the name of the function, but I disabled all breakpoint prompt just to make the following script that we are going to write clearer. So upon this breakpoint, let's examine the registers for send message to client call. Remember that for 64-bit systems, the parameters are passed through registers. And we just thought that might be that the first parameter that is passed in ICX, maybe it is a pointer to message structure. And if we dump it, we see familiar window handle structure. They're usually in the same format. Some small number, the second parameter. So this might be window message and window message parameters, W param and L param. So let's try another break. So let's examine ICX again. So we see different window handle and a different window message. So what we can do, we can now modify this breakpoint to add. Actually, let's first check what process we have. So the current process is Explorer from session 1. We try again. We get another breakpoint, but now there is also Explorer, but from session 2. So you see this Convergent Point works. So let's now modify the script for breakpoint code to add some scripting, some command. So upon execution, what we do, we dump process information, and then we use .print command to print parameters that we can get from ICX pointer, from a pointer that is in ICX register. So because we have nested quotes, we put them in slashes, and now we write something that we do very similar to print C function. So we need to dump handle to window message W parameter and L parameter. So let's put also columns. So we have 4 parameters and we put them after commas. Okay, so the first parameter is this one. So the second one, we need to add offset, pointer sized offset. Here we use pseudo register PTR size, and then we add more, but here we multiply by some index value. And then just 1 second. And then what we do, we put some line breaks for formatting. And what we need to do, we need to put go. So after each breakpoint is hit, we continue. So you see that breakpoint was redefined. And so we do resume and see what we get. So you see we get some traces with different window handles and messages. And let's do break. We see that all these breakpoint hits, they belong to different sessions. So this is all. I put this script, I put this log on debugging.tv later on today. So again, I repeat, we were able to put a breakpoint on some convergent point and trace from different processes. And finally, the usual slide of forthcoming training sessions and free webinars. Just know that there is a new forthcoming free webinar in July on generative software narratology. So you are welcome to attend. And so this is all for this episode. Thank you for watching it. Please later check out the slides and recorded video. The next episode should be, I think, next Monday. And we continue with live kernel debugging. Thank you for attendance. Bye-bye.